that the R group we know has the formula as CnH2n plus 1. So that means the mass of the R group will be basically CnH2n plus 1 must be equals to 43, and by calculations you can find out the value of n. The calculations will be something like this, that we know that we have n number of carbon atoms in CnH2n plus 1. So therefore the molecular mass of these n atoms of carbon will be 12 multiplied by n plus the mass of the hydrogen atoms, which are basically 2n plus 1. So therefore the molecular mass of the entire compound will be 12 into n for the carbon plus 1 into 2n for the hydrogen plus 1 into 1 for the again hydrogen. So therefore what we have got is basically 12n plus 2n, that is 14n plus 1 is equals to 43, which we have calculated the molecular mass of the alkyl group. So therefore the value of n which you will obtain is basically will be actually 3. So therefore in the alkyl chain of the RNH2 we will be having 3 carbon atoms. Now if you know 3 carbon atoms are there, then again we have 2 possibilities. One possibility is a straight chain, straight chain. Another possibility is again the branching. If you think about the straight chain one, then the value of the R will be CH3, CH2, 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 and if it is a branched one, then you can say the structure of R will be CH3, CH, CH3. Now again we have to decide what will be the structure of R out of these two which we have discussed just now. Now for to make a decision about it, we are also being given that after the evolution of the gas, the aqueous solution was distilled to give organic liquid which did not contain nitrogen, and on warming with the alkali and iodine it gives you yellow PPT. Now basically what we are doing is that in this case again you are reacting some compound with the I2 and aqueous alkali. So again that is a reagent for the haloform reaction. Now again I would say that the alcohol which will be formed from RNH2 must be a 2-degree alcohol. The reason behind it is that because the alcohol is undergoing haloform reaction, so in that case again we have to satisfy the conditions required, and the condition are as follows. First is that the compound should contain keto-methyl group, that is COCH3 group, and the second thing is that the compound or the alcohol which will be showing haloform reaction must have OH at the second carbon. So therefore the value of R or the structure of R to be a branched one. So that is why now you have the strong reasons to claim that the structure of the RNH2 will be something like CH3, CH, NH2, CH3, and the structure of the alcohol which is being formed by the reaction of the this amine, 1-degree amine, with the iodine and NaOH, that will fetch you basically yellow PPT because of the formation of iodo bond. So therefore the alcohol will be a 2-degree alcohol, and the structure I have already told you. So the name of that structured, you can see the name of the compound, that is alcohol in this case, will basically be the propane 2-ol, and the structure of A will be basically 1-methyl ethylamine. So what another name you can say is that propane 2-amine. Briefly we can say now that the amine will be basically a 1-degree one, yes, because it is giving you alcohol on reaction with NaNO2 and HCl, So for that matter, it is only and only the 1 degree amine which forms a 2 degree alcohol, and the structure of the alcohol will be basically propane 2-ol. Well, now let us discuss another example.